National 5 Maths, Practice Paper G, Paper 2. Now in question 5, we're given this trinomial here and it's been set equal to 0, and we've got to give the answer correct to significant figures, not decimal places, significant figures. So the fact is it's telling us to use two significant figures. It's kind of an indication it's probably going to be not a nice whole number answer. So to solve it, we're not going to factorise it. We're going to use the quadratic equation. Now that's given to you in the formula sheet, and it is x equals negative b plus or minus root b squared minus 4ac, all divided by 2a. So from here we can see that a is equal to 2, b is equal to 3, c equals negative 7. So we're going to sub these values into this equation here. So it's negative of 3. Now the reason I'm putting it in a bracket is just in case you've got any negatives to sub in, which we do in this case. We've got the c's negative 7. It just makes it a little bit easier to avoid making mistakes subbing in those negative values. So square root of b squared, so 3 squared minus 4 times a, which is 2, times c, which is negative 7, all divided by 2a. Now you do have to tidy all that up. This bit here under the square root, known as a discriminant, make sure you tidy it up to get a number there. Don't just type that whole lot into your calculator in a oneer. So that's going to give us negative 3 plus or minus the square root. Well, 3 squared is 9. Now this is where a lot of people make mistakes. You've got a negative, you've got a subtract here, you've got negative 7, but when you're multiplying all that together, you've got negative, going to give you a plus here. So 4 2s are 8 and 8 7s are 56. All divided by 2 times 2, which is 4. So it's negative 3 plus or minus the square root of 65 over 4. So in your calculator, you're going to do two things. You're going to do negative 3 plus root 65 over 4, and again negative 3, but this time minus root 65 over 4. So the two answers that you get are 1.2655, etc. And you get negative 2.765, etc. So it's telling us to use two significant figures. So the 1 is the first significant figure and the 2 is the second one. So the 2 is going to go up to 3 because of the 6 here. So your first answer is going to be x equals 1.3. And your second answer, well, there's your second significant figure this time. It's going to round up to an 8 because of the 6 here. And that is negative 2.8. So those are two answers. Now, in question number 6, we've got a set of data. We've got to calculate the median and the interquartile range. So to do that, we need to have the data in order. So it goes 37, 41, etc. Now, what I always recommend to do is once you've written out all your data, count up all the items of data to make sure you haven't missed any out, because it's quite easy to do that. And then you end up writing down all the wrong answers. I mean, you still get some of the marks for that, but you're not going to get all the marks. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, so I haven't missed anything out. Now, we're asked to find the median, that's the middle value. Well, if you've got 12 items of data, half of 12 is 6. So we're going to split it into two groups of 6. So it's in the middle of 58 and 59. So that has to be the median, which is Q2 equals 58.5. If it's not obvious as it is here, you just add the middle two numbers together and then half it, and that gives you that number there. So sometimes it's not as simple as just being able to tell just like that. We're also asked for the interquartile range. Now, to work out the interquartile range, you have to do Q3 take away Q1. So the interquartile range is Q3 take away Q1. Now, quite often they'll ask you about the semi-interquartile range, where you've got to do that and then half your answer, but it doesn't say that, it just says interquartile range here, not semi-interquartile range. It's more common that you'll see semi-interquartile range in the questions. So you've got to find the middle of the bottom half of the data. So you've got 6 items of data, so we can split that into 3 and 3. And then we've got halfway between 43 and 47. Well, if you're not sure what that is, you can add them together. That gives you 90, half of 90 is 45. So your lower quartile is 45. Splitting the top half of the data in 2, it's a bit more obvious, between 66 and 68, it's going to be 67, and that's your upper quartile. So Q3 take away Q1 is going to be 67 subtract 45, and that makes 22. As I said, if it was a semi-interquartile range you're looking for, you didn't have to half your answer, but it doesn't say that here. So our interquartile range is 22. Next, it tells us the teacher arranges extra, extra homework classes for their students before the next test in December. This time the median is 67 and the interquartile range is 14. So we can have before and after the extra homework. We can write down what the median is before and after, and what the interquartile range is. Well, the median before is 58.5, and the median after is 67. The interquartile range before is 22, and after it's 14. We have to make two appropriate comments comparing the marks in the October and December tests. Now, if you're going to compare the medians is a type of mean, so we can say the median score increases after the extra homework is given. You could also say by how much if you wanted to. Now, the interquartile range is a measure of how spread out data is. Interquartile range before is 22 and after is 14, so the number's gone down, so that tells us that the scores are less spread out compared to the median. So the interquartile range is lower, showing us there's less of a spread in the scores.